boy, I am so happy. I finally got my wire piercing probes. This is something when you want it now, but some things you gotta order them and you gotta wait for them to come. Those are only 15 bucks. I got 4 of them. What that's gonna do, some of them are spring loaded, but I don't like that. These you rotate, and as you do that, it sticks that little needle into the wire so you can measure it. Another method is back probing a connector, but I mean, take a look at this here. You ain't back probing that. And the idea is you probe it just enough to get contact with the wire, break through the insulation. That way you can take your readings and you don't stab it to death. Because being they're flimsy, they're probably stranded wires, and that's a great thing for that. This is my mass airflow sensor. I got a P0102 code, which is low signal. And with my scan tool that has a live data feature with the vehicle running, the grams per minute being shown for the mass airflow sensor is 0. And that's not good. So this is pretty state of the art. This is a hot film type. It has a chip here with everything integrated. It's got a little air passage, and then the air flows through a couple of these filaments. It's called a hot film. There's different types. You can have a vein type, which is older fashioned. You can have a hot wire, which when you look into your air duct, you can see literally a wire in there. This is it has the intake air temperature sensor built in. It's got 6 pins. I went ahead and took the liberty of labeling everything here. So 2 of the wires are for the intake air temperature sensor. That is a thermistor, and as air passes over it, it alters the amount of current that flows in the circuit, and this could be measured, and this could be interpreted as the temperature of the air. The mass airflow sensor has 4 wires. What it does is it measures the volume of air, liters per minute or grams per minute, the volume, the mass of air that's coming into the engine. It does that by superheating a wire. It's got a couple of filaments, and it compares the two. It's got all kinds of circuitry in here, and it's going to convert that into a signal. The red wire here is a 12 volt positive. The black and white, the black with a white stripe, is a ground. And then you have MAF return. Well, they just call it MAF ground. That's actually an ECM supplied ground. And this MAF signal wire is the one that we're having problems with. Now, normally YouTube and Google can walk you through just about any repair, and you can find the information that you need. But there are so many different types, and there's so many different ways that they work. There's ones with 3 wires, 4, 5, and then in this case 6. Well, for the MAF I have 4. But there's different ways that the signal works. Some of them use a 5 volt reference. The only way to surely know, because you didn't invent the damn thing and you didn't design it, you need to get the book that's made by whoever did. And this is my schematic diagrams for electronic engine controls. This is the gizmo here. So this is our IAT circuit. This K here, this is a ground that's shared with various other sensors on the vehicle. And what that means is that they're tied together in the wire harness before they go to the PCM. That's a gray and red wire, and that's a gray wire. And that does correspond to what I have here. This shit is confusing when you have different colored wires, and you have tan and light blue and red, gray and red. They look very close. So labeling them, you get your masking tape and a Sharpie. That's an easy way to label them, so it's easy. And then also when you're probing the pins, as this, you probe them this way. You want to be able to match up what's what. You can fry your PCM. It's the most expensive fuse on the vehicle. So when you go poking around, watch what you're doing. You also got to watch what your settings are on your multimeter. Now, the way this IAT works is from the PCM Powertrain Control Module, we have 12 volts, which goes through this pin here, and then that goes through a resistor. That knocks it down to 5 volts. That's a 5 volt reference. There's another spot here, and that is where a measurement is taken from the PCM, because when the resistance of this thermistor increases or decreases, it affects the entire circuit. And that is the point from where it's measured. I suppose it could be measured from here, but it's measured here. And then this, what they call the IAT return, is this gray and red ground wire here. Because every circuit has to have a ground. That's the tail end of it. It causes the current to want to flow and have a place to go. It says, ooh, it's chasing a ground, and it's going through these components. The mass airflow sensor, this is a very simplified diagram here. There's more than this going on. But here's your red wire, 12 volts. And here's your black and white, light blue and red, tan and light blue. This light blue and red is a signal wire. There's an element in there, and for 4 points on that element, they go into this little gizmo where they are processed. And the question is, well, is that a 5 volt reference? No. It is anywhere between 0 and 5 volts, and it's actually a frequency. The multimeter is not going to be fast enough or as capable as an oscilloscope to measure the square wave, the frequency, the times per second that it's shutting on and off. But it'll take an average, and well, I have hertz feature on there, so I can test the hertz, and I could see if it's putting out a frequency, and then I could see if it changes as you open the throttle. The signal return for the mass airflow sensor is an ECM supplied ground. That's your ground symbol. This here is not coming from the PCM, it's going to the PCM. After it gets all digested in here, this goes to the PCM. So what we're going to do is attach our leads here, and we're going to take our readings while the vehicle is running so we could properly diagnose if we have a faulty mass airflow sensor. Because you could have a bad ECM. You could have a pin on the ECM that isn't getting snugly fit by the connector. You could have a break in your wiring harness somewhere. A mouse could have chewed the wire. I went ahead and I tested my wiring harness where it goes and plugs into the ECM. I tested all of them. I got great continuity. And I tested these wires as well. You know. And what we're going to do, instead of throwing parts at a problem and being a jerk that buys parts and, oh, I replaced this and I replaced that and it still didn't fix it, please help. No. Or, oh yeah, I bought this and I didn't need it, so now I need to return it. Wink, wink, here you go, parts guy. I mean, we're going to diagnose properly. And then we could confidently make one trip to the store and get the part if we need to. This is another page in the book that has connector views, and it shows you, as you're looking at the connector, what all the pins are for. And you can see gray, gray, red, it's IAT, then you have your other 4 wires on the bottom for the mass airflow sensor. And it's good little tidbit information here because your voltage is supplied in start and run when the key is in the run or start cranking position. And that is overload protected. These other ones are not. The sensor, the signal wire, there's an output. This is not anything going to the mass airflow sensor to where you want to know what the ECM is putting out. This is coming out of the mass airflow sensor going to the PCM. There's another book that I don't have, I'm going to get. It is Powertrain Control and Emissions Diagnostics. And that is a book that will tell you exactly how to probe everything and what voltage should be what the resistance should be, to check if something is, if it's open or if it's supposed to be 1,000 ohms. That's a way that I could probably test this that way too. It's very, very detailed. And I didn't realize that. I thought these books, I got 3 books. I thought they were all, you know, all I needed, but I need to get that other book. How do you know how much to give it when you go poking that wire? You don't want underkill because then you won't get a reading. And that means you'll have a false reading. You don't want overkill because then you'll, you know, harm the wire. Well, that's why we're going to hook up our ohm meter and we're going to use our continuity beep to test that connection. The funny thing about these probes is that they take what looks like a headphone jack. It's called a banana plug, and I don't have that. The test leads that you buy for multimeters, I've looked at all of them everywhere, are like these. And there's nothing that you could shove in there. I've seen them. There's people that have them. I don't know where they're getting them from. But I'm just going to have to make do with, you know, sticking this in there. I have an alligator clip. Perhaps I could use that, clamp into it, but it doesn't fit. So, hey, it's better than nothing. These little sticks here are worth their weight in gold. There's, like I said, there's a spring type, but then you can't gauge how much force it's putting on it. And so I like the one that has the screw. And Fluke makes some which is good, well-made stuff, but they're too bulky. You know, when you have a tight spot and you got a wiring harness, well, 100 wires, I mean, you need something that fits in there. And these are good. And I like having 4 of them, because I'm going to put all 4 on my mass airflow sensor and test each one. I don't have to skip around. I can make these all up here on the bench, go out the vehicle, plug them in, piece of cake. There we go. Just like that. Got great continuity, 0 ohms resistance. Hardly even had to spin it all that much. It is in there. And then, you know, when you're done, you can take a little dab of nail polish and put it over the hole. And there's a little hole they hardly be able to see. It means you don't have to hack up your harness. Wow. Being that my little probes here don't have a way to hook up to the multimeter a nice secure manner, I have to probe each one. They need to be right here in front of me. They can't be down in the engine upside down where I can't read any of the tags. That's a recipe for disaster. But they did work great, and I went ahead and I tested each one of these wires. I don't have a hands-free cell phone holder just yet, but I can tell you the wiring harness would have been too tucked in there for me to take a reading of it with the engine running, but with the key on and simulating with the can of duster here, squirting that in there, I got 0 volts, 0 hertz. This mass airflow sensor is dead as a doornail. All the other wires I got good grounds, good 12 volts. Signal wire, not so much. So I'm a happy camper. Oh yeah, got the new part, and it's made by Hitachi. The Japanese, very good at making electronics. So, go ahead and slap it in. A little trick that I like to do is put some petroleum jelly all around the connector, in the connector. Makes it easier to get it on and off. So you can wrestle with these things and they're stuck. Helps with hoses and stuff too. And you know, of course, you use the little itty bitty channels to get stuff off so you don't yank on wires. But it works good. A little bit of Vaseline. Oh, it's a wee bit fiddly getting all the bits together. I noticed there's holes in there. It's not entirely a cold air, fresh air intake. Right then, moment of truth. We have installed the component and it is working beautifully. Mass airflow, pounds per minute, 0.85, 0.83, 0.82. Outside air temperature, 81. It feels like 101. Intake air temperature, 91. That's a lot better than the 120 that it was saying when it was 70 degrees outside. Ooh, we up the RPM. Woo, number goes up. So yeah, problem's fixed.